When I left you at the end of the last lesson, I left you with both the unbalanced and balanced equation for the reaction of sodium metal with water to give sodium hydroxide and hydrogen gas. So what I propose to do in this lesson now is go through the details of how do we go about balancing an equation. But first I want to take a moment to look back and look at this big picture and ask the question, what does a balanced equation mean? Well, what this equation means is to generate one molecule of hydrogen gas, the reaction uses up 2 atoms of sodium metal and 2 molecules of water, and then also generates 2 quote-unquote molecules of sodium hydroxide. I put molecules in quotes because sodium hydroxide is actually an ionic compound, and the technically correct term is, formula equivalence. But for the purposes of balancing the equation, if you think about it as molecules, it'll be just fine. Okay, so how did I go about balancing this equation? Well, first I'm going to give you the rules, and then we'll go over how I applied them and how I balanced each element. Okay, so the first rule is to look for elements that appear in only one term, one element or compound, on each side of the equation, and adjust the balancing coefficients so that the number of atoms of the element on both sides, including any subscripts, is the same. The second rule then is to balance the elements that appear more than once on each side, and then after you do this, you might have to go back and look at other elements you have balanced again and make further adjustments. We'll see this in practice. And then finally, you are done when you have the same number of atoms of each element on each side of the equation. Okay, so for our first example, sodium and oxygen are the elements that appear only once on each side. And if we look at this equation, at the moment, the unbalanced equation, those two elements are actually already balanced. There is 1 sodium on the left side and 1 sodium on the right side. There is 1 oxygen on the left side and 1 oxygen on the right side. But hydrogen is not balanced. So hydrogen appears in both terms on the right side, and there are a total of 3 atoms of it. So there's 1 hydrogen atom in the NaOH, and then there are 2 in the H2. However, we only have 2 atoms of hydrogen on the left side in our water. So we clearly have to increase the amount of hydrogen on the left side. Okay, so there's a little bit of trial and error involved in balancing equations. So what we're going to try is putting a 2 in front of the H2O on the left side and see what that does for us. That gives us 4 atoms of hydrogen on the left side, but we have 3 atoms of hydrogen on the right side. So can we adjust one of the coefficients on the right side to increase the number of hydrogens by only 1 and get it to match on both sides? Well, you're not going to want to do this with the H2, because if we multiply the H2 by 2, that's going to give us 5 hydrogens on the right side. But if we put a 2 in front of the NaOH, that will do the trick. Okay, so where we are now is sodium plus 2 waters gives us 2 NaOHs and H2. So where's the problem? Well, hydrogen's now balanced. Oxygen is balanced. We added a 2 to the compound containing an oxygen on each side, but now sodium is not balanced. There's 2 NAs on the right side and only 1 Na on the left side. This is easily corrected by putting a 2 in front of the sodium on the left side, and then this gives us the fully balanced equation. 2 sodium plus 2 waters gives 2 sodium hydroxide and 1 H2. For our second example, we're going to look at a very, very important reaction in chemistry, which is the reaction of nitrogen gas and hydrogen gas to give gaseous ammonia. So this is actually called the Haber process, sometimes called the Haber-Bosch process for the synthesis of ammonia. This is still how ammonia is synthesized today, and ammonia is an important constituent in fertilizers. And this process was discovered during World War I, and it was recognized with the 1918 Nobel Prize in Chemistry going to Fritz Haber. So in this process, we have two nitrogen atoms on the left side, N2. Okay, so remember, we got to count the subscripts. There's two nitrogen atoms on the left side and only one nitrogen atom on the right side. Okay, so if we want to balance nitrogen, which is the one that's easiest to deal with first, let's put a 2 in front of the NH3, and that balances nitrogen. 2 on the left side, 2 on the right side. Okay, but now we have 6 hydrogens on the right side, right? Because we have 2 NH3s, and each NH3 contributes 3 hydrogens, so 2 times 3 is 6. And only 2 hydrogens on the left side. So what we have to do then is multiply the H2 by 3. The H2 on the left side, so N2 plus 3 H2s gives you 2 NH3s. And the equation is now fully balanced. Okay, I want to just put one word of caution at this point, and that is when you're balancing equations, you can only change the coefficients. Those are the numbers in front of the formula. We can add 2's and 3's before the formula. You cannot change any of the subscripts. So for example, if a student tried to just balance this by saying N2 plus H2 gives you N2H2, you're no longer forming NH3. You're no longer forming ammonia. You would actually be producing a different chemical. So don't ever touch the subscripts when you're balancing an equation. Okay, so then for our final example in this lesson, we will look at the combustion of methane or natural gas. Okay, so many of you are doing this in your gas furnaces or boilers or water heaters. Okay, so the reaction, methane is CH4, again a fairly small molecule, but this is an organic molecule, and it reacts with oxygen, of course at high temperatures, to give carbon dioxide and water. And these products, at least initially, are in the gas phase. Okay, so what we sometimes do, especially now that we're getting involved with 3 different elements to worry about, is we can label on each side how many atoms of each element we have. Okay, so the left side has 1 carbon, 4 hydrogens, and 2 oxygens. The right side has 1 carbon, 2 hydrogens, and 3 oxygens. So, following the rule to look for things that only appear in one place on each side of the equation, carbon is a logical place to start. And luckily for us, carbon is already balanced. Okay, so next let's turn to hydrogen. Hydrogen only appears in 1 molecule on the left, CH4, and 1 molecule on the right, H2O. Okay, so we have 4 hydrogens on the left side, 2 hydrogens on the right side, and we can balance that by simply putting a 2 in front of the H2O on the right side to give us 4 hydrogens on the right side. Finally, we need to balance the oxygens. Okay, so we have 2 oxygens on the left side, 4 oxygens on the right side at the moment. So if we put a 2 in front of the O2 molecule on the left side, that will do the trick. And from our bookkeeping, we can see that we have the same number of atoms of each element on both sides of the equation. Okay, so that's our lesson on balancing chemical equations. And now we will move on in our unit on chemical reactions and start coming up with a classification scheme for chemical reactions.